In order to demonstrate how the body adapts to periods of fasting, let's use the analogy of a factory with a large wood-burning furnace. Imagine that this factory sits on the edge of a river. Throughout the factory, there are several large furnaces that burn wood to produce energy to run the factory. Each day, 3 large boats bring in shipments of trees. The workers unload these different types of wood and cut them into logs small enough to put into the furnace to burn for energy. Sometimes, when the shipments of wood are really large, there are extra logs which can be taken outside, wrapped up into big bundles, and stored in a large pile behind the factory to use later. Now, let's imagine what happens when all of a sudden the boats stop coming in to deliver shipments of trees. The factory workers will quickly run out of logs, and the fire will start to cool down. The first thing that the workers can do is bring in the extra logs that were stored outside the factory. Let's take things one step further, and imagine that the supply of stored logs starts to run out. As the furnace starts to cool and energy starts to run low again, there is one more option to keep the fire burning. The workers can take pieces of wood that are laying around the factory, like books and furniture, and burn that for energy, until, eventually, everything they can possibly burn is used up. The analogy of the factory is similar to how the cells in your body function. The factory represents a cell in the body, and the furnaces represent a part of the cell called the mitochondria, which take nutrients from the food that is eaten and turn it into energy that the cells can use to function in the same way that a furnace burns wood, to create energy to run the factory. The shipments of trees represent different carbohydrates that come from the food you eat. Carbohydrates are nutrients that can be broken down into glucose, a type of fuel that the mitochondria can easily use to produce energy. The extra logs that are bundled up for later use represent fatty acids that the body stores in fat cells. During a prolonged fast, the body does not have enough glucose and has to switch to stored nutrients like fat for energy. In extreme cases, the body can start breaking down proteins like muscle and connective tissue in order to get amino acids to use as energy. People with anorexia respond differently to periods of fasting, though. Let's go back to the analogy of the factory. Imagine that there is something wrong with the door to the furnace, and the workers are not able to open it to put wood on the fire to burn. The bundles of logs and pieces of furniture are still brought to the furnace, but now they start to pile up on the factory floor instead of being used to fuel the furnace. A supervisor comes in and sees the logs and pieces of broken furniture piling up on the floor. The supervisor mistakenly believes that there is plenty of fuel available and cancels any further shipments of wood. Something similar to this happens in anorexia nervosa. People with anorexia are more likely to inherit mutations in genes related to using fatty acids and amino acids as a source of energy. Because of these mutations, their bodies respond differently to prolonged fasting. When they fast, the body still releases fatty acids and amino acids, but now, the mitochondria are not able to use these molecules to make energy, and the amino acids and fatty acids start to build up within the cell. This accumulation of amino acids and fatty acids activates a nutrient sensor in the cell called mTOR. mTOR acts like the fuel gauge in a car, telling the cell how many nutrients are available. When nutrient levels are very high, mTOR gets activated and tells the brain to stop eating because it incorrectly concludes that there is an abundance of nutrients. In the same way, the factory supervisor stopped shipments of trees when they saw the piles of wood.